Remember from section 2.6 we started manipulating our graphs of sine and cosine, and we were paying attention to our amplitude, that is our minimum maximum values, and then we also were paying attention to the period, and if we have a value here then we can take the period 2 pi, divide by that value, and that's going to then determine the period for our graph. So if we look at this first one, we have y is equal to 2 times the sine of x. So remember that sine originally begins right here at the origin, so that would be our first critical point. So as we're doing these, we really want to focus on those critical points, and wherever it begins, we know that the period has not been changed, so it's going to end at 2 pi. So it's beginning and ending in the same spot. We also know that halfway in between there, we're going to again cross that x-axis. Now because the amplitude here is 2, rather than having halfway here at 1, now we're going to double that. Now our maximum value at that point is going to be at 2. We also know then that the minimum value in between these two is also at 2. So then we can sketch our graph for y is equal to 2 times the sine of x, and that is where that value goes. We would know then that we would also continue on through here, have another max here, cross again there. Same idea on this side, we have another minimum value there, cross the x-axis again here, so we could continue that and show what happens with this graph. Now the next one, we have y is equal to cosine of 2x. Now this time, now we're looking at the period. Remember our period for cosine and sine is normally 2 pi. Now this time we're dividing by that 2 value, so that shortens this up. So now we're going to say that we're going from, instead of stretching this out, I'm going to go, here is pi, so this is going to be pi over 2, and this is going to be 3 pi over 2. On this side now we're saying negative pi over 2. And cosine, we normally start off up here at 1, and because the period is pi, now we know we're going to end then in the same spot also at 1, right? And then halfway in between there is where we hit our minimum value, going to be right there at negative 1. Halfway in between there we cross, halfway in between these two we cross. So now we can get an idea of what that cosine graph looks like going that way. Alright, and then we could again cross here, have another minimum. Cross here, have another minimum, so we can see that that graph continues, and we see the wave there when our period is changed. With that in mind, now with section 2.7, now we're looking at secant and cosecant. Again, our amplitude is going to be the a value, and our period for these two still 2 pi. And now we're going to add a vertical shift. So if we have a plus b, we're going up, minus b, going down, so that b value is going to be our vertical shift. Now, critical points for secant and cosecant are the same critical points we had for sine and cosine. So when we do these two graphs, what we really want to pay attention to are the graphs that we just finished doing. Those same critical points for the ones that we just finished are now going to be critical points for these two graphs. So here we have y equals 2 times the cosecant of x. So if I think about my critical points for sine for this same graph, and we just did it, we know we begin at the origin, we're going to end at 2 pi. We cross the x-axis here, we have a max value there, we have a min value here, and that gives us those critical points that we had for sine. Now remember, anytime we cross the x-axis, now for cosecant, that's going to be an asymptote, because now we're talking about sine, or 1 over sine, and so that's a 0 value. We would also have one over here, all those multiples of pi. So now we have these asymptotes that we have to watch out for. Now, remember also, now this was a max value for sine, it's now a minimum value for our cosecant graph. And this was a minimum value for sine, it's now a maximum value. And so we have these parabolas, and Our amplitude is 2, so we know that each one of them is at 2. Here's a minimum. Over on this side, again, now we're at -2. There's a max for this parabola. So if we pay attention to the critical points of sine, that again gives us our critical values for cosecant. Now we have y equals the secant 2x. Same idea. Now we have 2 pi divided by 2 gives us our period of pi. So going back to those critical points that we had before, here is pi over 2, pi, 3 pi over 2. On this side we're having negative pi over 2. And again, we had started at 1, period is pi, so we're going to finish at 1. That was a critical point we had. We also had a minimum halfway in between those. So those are going to be critical points for our secant graph. Now remember, halfway in here, we cross the x-axis. Halfway in between these two, we're crossing the x-axis. Those are now going to be our asymptotes. So I would have another one here. Have another one over on this side. So now when we look at these values, again, our maximum value for cosine becomes a minimum value for our secant graph. A minimum for our cosine now becomes a maximum for secant. So now we end up with our graph that looks like that. Also in section 2.7 we're looking at tangent and cotangent. Alright, still the same idea with our amplitude values here. The period now for tangent and cotangent, remember, is only pi. So if we have a value in here, now we're taking pi divided by that value to look at the period. And again, b is our vertical shift. So if we look at these two graphs, we have y is equal to 2 times the tangent of x. Remember that our asymptotes for tangent are going to be at pi over 2, negative pi over 2, and we cross the x-axis at the origin. All right, and remember that we said when we were at pi over 4 that our sine and cosine values are the same, so that is where we are equal to 1 for tangent. But now that we have an amplitude of 2, that's going to scoot that point up. And then same idea on this side, scoots this to -2. So now we have our graph comes across this way. And again, we have those asymptotes here where it's going to approach but never touch. Now let's say that we take this value, 2 times the tangent of x, and we add a vertical shift. Let's say we have -1. What we're going to do then is we're going to subtract 1 from each of those critical points. So now I'd have a point here. I would have this point drops down 1 to here. This point drops down 1. So we have that same graph now with those critical points down 1. If we have y is equal to the tangent of 2 times x, now again the period, t is equal to pi over 2. So now instead of having that asymptote here, we have shrunk this down. So now our period, we're going to still go through the origin, but now that asymptote is here at pi over 4 and here at negative pi over 4. It's also going to squeeze those points in, so now halfway in between there is where we hit 1, and halfway in between here is where we hit -1. So it's going to make that a skinny graph like that.